This is Professor White, and today we are going to look at the graph of sine function. So I'm going to try to make this as painless as possible. Let's remember what sine did and kind of remember the major angles that we dealt with before. 0, pi over 6, pi over 4, pi over 3, pi over 2. And at 0 it was 0. We derived this in the previous video. Rad 2 over 2, rad 3 over 2, and 1. So it's increasing and it's positive in the first quadrant. And the other thing that you need to memorize, it's positive here. It works like y. Positive, negative, negative. So it's going to do the, similar thing in the positive side, and then it's going to be negative on the negative side. If you want to draw the basic sine function, and we know the period, we also looked at that in the past. The period is 2 pi. And we also know that sine of negative x is negative sine x. So it is an odd function, symmetric along the origin. So if I can do this 2 pi period, just start with 2 pi, go in the middle, and then middle of pi, and then this one, so you have 1, 2, 3 of them, 3 pi over 2, and then middle of pi over 2 is pi over 4. So I'm going to do this one, so we start with 0, if this is 1, and it's going to go up to 1. And I know that on the other side, in the second quadrant, it is positive. It's going to go just the opposite because it works like y. Think about it. This is the same y. It's the same y. All right, so it's going to do the same thing and hit back to 0 when you're here. And it is an odd function. In other words, it's going to do this thing on the left-hand side. So if you go to negative pi over 2, and then negative pi, all right? And what is it going to do on the other side? You are in the negative. The values are going to be the same, but what it's going to do is it's going to be simply negative. So it is an S, sinusoidal wave kind of thing. That's what your basic sine function looks like. Just remember, starts at the origin, at the 0, and it just goes, wiggles once, and hits 2 pi, and then kind of repeats itself. Now, when we put this concept together with the translations, this is what we're going to do. We're going to have an A, sine, B, x minus c plus d. I just put it all together, and I'm going to do, a graph in detail. So what this does, the number in front of sine, it just makes it longer. So it changes, if it's longer if it is a whole number or fraction that's bigger than 1. It's going to make it longer. It's going to get it pressed shorter if it is less than 1. And it's going to reflect it if it is negative. So that changes what we call the height of your thing, changes the magnitude. The magnitude is pretty much the height here. It's going to change that. Now, what this is going to change is it is going to change the period. What it's going to do is it's going to squish it this way or kind of extend it out, and it's going to take your initial period and then divide by b. So if the b is a whole number bigger than 1, it's going to make it squished. If it is, less than 1, it's going to make it longer. Now, what this does, this is going to do the phase shift, and it's going to move your graph right or left, okay? So if it is negative, it's going to move right or left. What this is going to do, it's going to move it up or down, up or down. Okay, so we're going to take a regular sine function and we're going to do things to it. So let's get started. Let's say I want to graph this. Y equals -3 sine, and I have a 2, x minus pi over 2 plus 4. All right? So let's draw our regular sine. This is your x, and this is your y, and this is at 1, and this is at 2 pi. All right, very good. Now what we're going to do, I'm going to start with the period. So this is my sine. I'm going to start with the period. What did the period do? It got changed based on this number. So my new period is going to be 2 pi over 2. So what happened to it? It's going to be squished to pi. So my period is going to be like this. All right, so this is pi, pi. Nothing else changed. So this is the picture of sine 2x. Now, this is what I'm going to do. I'm going to make them a little bit bigger. So let's look at the function. What did this do? What this did, it moved it to the right by pi over 2. So here's my pi. This is pi over 2. So what's going to happen is it moved it to the right. So if I draw this sine of 2x minus pi over 2, okay, it's going to move it to the right at pi over 2. Okay, well, where is this going to end then? So you had pi over 2, and your period is pi. So that is pi over 2 plus 2 pi over 2, which is 3 pi over 2. So this ended at 3 pi over 2. Okay? Now what else am I going to do? I will go and move that up 4. So I'm going to draw sine 2x minus pi over 2 plus 4. So it's going to start at pi over 2. It's going to end at 3 pi over 2. And it was at 0. It is going to now be at 4. So that 0 is going to be at 4. And the size did not change. So it's going to be up 1 at 5, and then down at 3. Oops, let's draw this a little bit better. Let's go in the middle. All right, that's what we have. Now, what am I going to do next? It is going to be, so this is, okay, I just took some notes so that I don't make any mistakes. All right. It is going to change the magnitude by 3, okay, when I put the 3 in there. Okay, so what it's going to do, it's going to start at 4, but it's going to go not 1 step, but 3 steps. So it's going to go 4, 5, 6, 7. It's going to go all the way up here. And then 4 minus 3, so it's going to go all the way down here. Here we go. So that's the picture of that. And what will happen last, it is going to have this negative. So, and that's going to complete. What does the negative do? It's going to reverse it. So the green is the final graph of that. Sine translated any which way, every possible way that you can play with that. And that is the end of your sine graph. Please watch this video one more time if you kind of lost track of what we did.